Hi there and welcome to Code Framer. So in the last video we understood about the open and close principle, and in this video we will continue to understand about Liskov substitution principle. So as I said earlier that if you try to understand this particular principle using its definition, it will be little vague actually. Unless and until you have extremely good understanding about object-oriented programming, it will be little difficult to understand about this particular design principle using its definition alone. So it becomes very important to understand this particular design principle using an example. So I'm going to use two examples to explain this particular design principle, because first example will be a very straightforward example which will clearly explain to you what is Liskov substitution principle and what exactly it means. But the second example that we are going to see will be a little tricky actually, because sometimes there will be situations where we will write a particular class based on its responsibility and it will work basically fine, but unknowingly we could have breached the Liskov substitution principle. So sometimes that happens, and I found a very good example. I think I found this example in Geeks for Geeks, and I thought that example was really interesting because sometimes you really have to concentrate on the details in order to find whether are you breaching any particular design principle or not. So I think it will be really good if we discuss that second example as well. So pay complete attention to this video right from the beginning to the end, because once you have seen this video, I can assure you that you will never have any kind of doubts in this particular design principle. And also in future when you are coding, this design principle will always stick to your mind. So having said that, let us begin. So first of all, let us see what is Liskov substitution principle, right? So Liskov substitution principle basically states that any derived class, which is basically derived from a base class, so any derived class should assume that it can substitute its base class, right? Which means if you create an object from your derived class, then that object should be able to substitute the functionality of the base class as well. So I know that this definition is little vague, so now let us have a look at the example. So as part of this example, just imagine that you are a developer who is working for a client, and that client is owner of a showroom, a vehicle showroom. Now initially that particular showroom has, say for example, two vehicles, or you can say two categories of vehicles. So on one side you have different cars to sell, and on other side you have different motorbikes to sell. Now the client comes to you and he gives you a requirement that he bought a new robot in the particular showroom and he wants you to code that particular robot. So the functionality that the client is expecting out of that robot is to have a daily health check of all the vehicles in the showroom. So what he wants is that this particular robot should go to all the vehicles, each and every vehicle, and perform some basic health checks or vehicle checks so that he can know every single day that all the vehicles in the showroom are working fine. So now it's your responsibility to write a particular class, or basically to code the robot to perform the vehicle checks. So in order to do this, what you will do? So let us say you create a class for this. So let us write class and let us name this class as vehicle check. So this is the name of our class. So in order to perform the vehicle checks, you will basically check the components of the vehicle, right? So what are the different methods that you would require in order to perform these checks? So say for example you want to check the wheels of the vehicles. In order to do that, you will write a method def check wheels, right, which will take self, and inside that method you will write some code to check wheels, right? And then you will return the status of the wheel. So this will be one method or one component of the vehicle that you would want to check. The second component can be the body of the vehicle, right? So you would like to check the body, whether there are any scratch or is there any damage or any kind of problem with the body of all the vehicles. So in order to do that, you can write a method check body, and then again write some code to check body of the vehicle, and then you will return something. So you can say body status. And now let us also include engine, and you can also include maybe the battery of the vehicle. So you can write two methods quickly. So check engine, and also you can write check battery, right? And we can copy paste these lines of code here. So here you will check the engine, and here you will check the battery, and you will respond with corresponding status. So basically this is how you will write the methods inside this particular class, right? Because you would want to check the different components of a particular vehicle so that you can ensure that everything is working fine. So now you have implemented a vehicle check class which you can basically use to perform all the steps related to the vehicle check for different categories of vehicles. So as I said that you have two categories of vehicle, right? You have certain cars to sell and certain motorbikes to sell. So you can create a specific class for car. So you can say class car check, and you can basically inherit the vehicle check class inside this. And now you can simply implement all these methods inside this particular car check method, right? So you can basically implement these methods and you can basically customize this method to perform specific steps to check the status of the car. Now similarly, you also have to perform vehicle check on all the motorbikes. So for motorbikes, you can create a separate class. So you can say class bikes, and again you can pull the same vehicle check class inside bike, and again then you can simply pull these code and implement the same methods inside this particular bikes class. So as you can see here that all our categories of vehicles are covered now, which means that using this code, the robot can go to each vehicle on a daily basis, perform the vehicle checks and return certain output to the user, using which the owner can be satisfied that on a daily basis all the vehicles are in good shape and condition. So which means that you are happy, your client is happy, everything is going good. So now let us take one more scenario. Say for example, after few months, the manufacturer sends a new consignment. Now in this consignment, along with the car and bikes, the manufacturer also sends some bicycles. So which means that now, apart from the car and bikes that the client had, he also has some bicycles to sell in the showroom, which means that you as a developer have to accommodate bicycles as well into your code so that the robot can perform the daily vehicle checks on bicycles as well. So which means that you have to somehow accommodate bicycles into your code. So in order to add the bicycle, of course, what you can do is you can create a separate class. Just how you created a separate class for the car and the bike, you can create another class for bicycle. So if you do that, so say for example, we write class and this time we write bicycle, and again we inherit the vehicle check class. So now here, as we did earlier for bikes and cars, we can simply implement these methods inside bicycle as well. But I hope that you're noticing something here. Something is fishy here if you notice carefully. Check wheels is fine. You can use that particular method, or you can basically reuse that method from your parent class, right? So that is fine because bicycles has wheels, so you can check wheels, and bicycles has body as well, so you can check the body as well. But what about engine and battery? Bicycle does not have an engine or a battery, right? So which means that these methods are completely irrelevant to this particular class because it cannot be used. That doesn't make any sense because bicycles simply don't have engine and battery. So immediately as a developer, what you will think, I know, which is to simply remove these two methods and continue to reuse the vehicle check class. And if you think about it, you are absolutely right, because this will work, because functionality wise, if you implement this code into your robot, there shouldn't be any problem. So as far as the cars and bikes are concerned, it will perform the health checks on the wheels, body, engine and battery. But when it comes to bicycle, it will simply perform the vehicle checks only on the wheels and the body, which is absolutely fine when it comes to the functionality as such. But here, unknowingly, you are breaching the Liskov substitution principle. So remember what Liskov substitution principle states. It states that your derived class must be able to substitute your base class. So here, as you can see, that your derived class is unable to substitute your parent class because it is not implementing check engine and check battery methods of the parent class, which clearly means that it cannot substitute the parent class. Yes, some of the features of the parent class this particular derived class can use, but as far as all the functionality of the parent class is concerned, your derived class cannot use it, which means the derived class here in case of the bicycle is not substitutable to its parent class. And this is exactly where we can breach the Liskov substitution principle. So if you think about it, your code will work fine. If you install this code into your robot, it will work fine. It will go and perform the vehicle checks based on methods that you have defined in each class, be it the car, be it the bike, or be it the bicycle. But as far as the design principles are concerned, you are breaching Liskov substitution principle. Now, having understood how we can breach Liskov substitution principle, now let us have a look at how can we make it right. So how can I accommodate this bicycle into this code without breaching the Liskov substitution principle? So that is the question. So in order to do that, what you can do is you can create a new class here, a separate class to handle the vehicles which does not have engine, right? So you can write a class and you can name it vehicle check without engine. And then here you can basically inherit the parent class, which is the vehicle check class. And now inside this class, you can implement only the methods which is required for the vehicles which is not having an engine, which means that you can simply copy paste these two methods and implement these two methods inside this particular class. And now once you have implemented this class, which is vehicle check without engine, and you have basically implemented only the methods which are required for this particular class, or the methods which are relevant to the responsibility of this particular class, now for the bicycle, or instead of using the vehicle check as the base class, you can use vehicle check without engine as the base class. So now as you could see that the class bike bicycle will be substitutable to its base class, which means that now we are not breaching Liskov substitution principle. So this is how you can correct this, and this is how you can avoid breaching the Liskov substitution principle. So I hope that this example makes sense. So whenever you are writing a particular class and you are inheriting that class into a derived class, just always remember that the derived class must be able to completely substitute the parent class, which means that all the methods and behavior or members of your base class should be usable inside your derived class. Only then you can ensure Liskov substitution principles implementation and guidelines inside your derived class. So as you could see here that in our car check class, where we have inherited from vehicle check, we were able to implement all these 4 methods which are implemented in the vehicle check. Similarly, in the bikes class, we were inheriting from this vehicle check. So vehicle check was our parent class, and we were able to implement all the methods of my parent class into my derived class. And again, inside the bicycle class, I created a separate class, vehicle check without engine, and I have implemented only these 2 methods, which is check wheels and check body, right? And now inside my derived class, I was able to use these 2 methods which is available inside my parent class. So this is how you can basically ensure that you are following the Liskov substitution principle diligently. So if you are wondering that if the child class can substitute the parent class, then what is the use of child class? Why not use the parent class alone? Then answer to that question will be that whenever you are using a parent class in order to create a derived class, of course you can add newer methods and new features into your derived class. No doubts about that. But what Liskov substitution principle basically states that whenever you are creating a derived class from a base class, then the behavior of that base class shouldn't change, which means that all the methods that are available in the base class should be usable inside your derived class. And when your derived class is instantiated, or when you create an instance of your derived class, it should be able to substitute your base class without altering the correctness of the program. So this is what Liskov substitution principle basically states. So this is one example which is a straightforward example, right? So as you could see here that by simply thinking about a derived class as a class which could basically mimic all the methods of your base class, you can basically follow the Liskov substitution principle. So this is like a very simple example, but there is one more example that I want to share with you, which is a little tricky, because in this particular example, you will notice that you won't even realize, but you would have breached the Liskov substitution principle. Here it is quite evident, right? In this particular example that we saw just now, it is quite evident that you are breaching Liskov substitution principle. But the next example that I'm going to show you, it will be very tricky to find that whether I am breaching Liskov substitution principle or not. So in the second example, I'm not going to give you any stories. So we will directly implement 2 classes where we will try to understand that when are the situations where we can end up causing certain side effects if we do not follow the Liskov substitution principle. So in order to implement these 2 classes, what we will do is we will create a rectangle class which will simply take a width and the height as an input from the user, and basically it can return area of that particular rectangle from a method area where we will simply multiply the width and the height. And also we will implement some getter and setter methods using which we can basically get the width of the rectangle and also the height of the rectangle, and similarly we can set the height and width of the rectangle. And then we will create a square class which will be the derived class from the rectangle class. So now let us start coding and see how these 2 classes basically functions. So first of all, let me write class, and we can name this class as rectangle. So first let us define the constructor of this particular class. So we can say def init, and then we can take width and height as the input, and then we can simply store this width and height into an instance variable. So we can say self.height, and we can store height, right? So this will be our constructor. So now let us define the area method, which will basically multiply this width and height, and it will return the area of this rectangle. So we can use the property decorator here, and then we can write def, and the name of the method will be area. It will simply return self.width multiplied by self.height. So this will be the area method. So it's a quite simple method. So it will simply return the area of the rectangle. Now let us just implement one string representation so it becomes easy for us to just see what is the width and the height of this particular rectangle. So we can say def, and then we can create the string method, and inside that we can simply return an f string which will just return us the width, which will be self.width, and also the height, which will be self.height. And now let us implement the getter and setter methods. So first we can declare the getter method. So we can again use the property decorator, and then we can write width, and this will basically return the self.width. width, and then we can define the getter method of the height. So again we can use the property decorator, and then we can write height, and this will simply return the height of the rectangle. And now let us implement the setter methods. So in order to define the setter method, we can use the width.setter decorator or the attribute name.setter decorator. So we can say width.setter, and then we can define our setter method, and we can name this as width, and which will accept a value as an input, because since we are going to set the width, so we need an input value from the user, and then this will simply set the width of the rectangle. So we can just copy the value into the self.width instance variable. And similarly, we can just create the setter method for height. So we can simply copy paste this method. So we can here just replace width with height. Again, it will take input as value, and then simply it will update the height instance variable with the value. So this is how we can implement this particular class, where as you can see that we have taken the width and height as the input parameter for this class, and then we are declaring the instance variable for width and height, and then we are declaring the area method where we can calculate the area of this particular rectangle by simply multiplying the width and the height. And then we have declared a string representation where we are simply displaying the width and the height of the rectangle, and then we have declared some getter and setter methods using which we can basically access and also set the width and height of the rectangle. So this is our rectangle class. Now let us declare our derived class, which is the square class, right? So in order to declare the square class, we can write class square, and here we will inherit the rectangle class. So rectangle class will be our base class for this derived class. So we can say rectangle, and now we will declare the constructor of this particular square class. So we can say def init, and remember that here we have to take a single input from the user, right? Because when it comes to square, both height and width are basically the same. You don't have to really take different inputs from the user for width and height when it comes to square. So you can take only one single input from the user. So you can say that you can take size as the input parameter from the user. Pardon me, here you have to mention init, and then inside this particular constructor you can call the constructor of your parent class, because remember you have taken the input from the user for the square class, but you have to use the area method which is inside your base class, right? So which means that you have to pass this size input parameter that you have received in the square class to the constructor of your base class, so that you can define the width and the height of the rectangle base class, right? So you can define those attributes which is there in the base class, height and the width, using this particular size variable that you have received in the square class. So you can say rectangle dot underscore init, and then you can pass self as the first argument, and then you can simply pass size twice. So when you are sending size here inside this rectangle's constructor, you are basically sending the width and height of this particular rectangle class, and you are sending the same value in both width and height, and which is quite logical when it comes to a square class, right? Because when it comes to square, both width and the height are the same. So logically this is right. Now let us just implement the setter methods inside our square class. Now the reason why you have to implement this setter method inside a square class is because when you have instantiated the square class, and later if you want to change a specific value of the square class, be it the width or the height, then both width and the height should become the same. So say for example, if you want to change the width of the square, then height should also become same as the width. And similarly, if you change the height of the square, then the width of the square should also change to the height of the square, which means both these values should be same at any given point of time. So you can define the setters as follows. So you can write at rectangle.width.setter, and inside this decorator you can say def, and then you can write the name of the attribute, and then you can take value as an input to this particular method, because you would want to take an input from the user in order to update the width of the square object, right? So we can take the value as the input, and now we will simply update both width and the height as the value. Okay, there's something wrong here, so I think this is a comma, so I'll just update it with dot here. So I think now this IDRL will go. Okay, so here we have updated both width and the height with the value that we have received by the user to update the width of the square object, right? Because once user is intending to change the width of the square, then automatically the height of the square should also become the same as width, because this is a square and not a rectangle. And similarly, if the user sends a value for height, let us just change, then you can use the same method. So you can just change the weight to height, and here it remains the same. So now using these two setter methods, if the width or the height of the square object is updated by the user, then in that case both width and the height will become the same, and you will get the area of that square object accordingly. So now we have implemented both the rectangle class and the square class. Now let us create a program where we can basically use these two classes and see how basically they are generating the area of their respective objects. So first let us create a function. Say for example we can write def and then we can name the function as useIt, and then inside this function we can pass an object, and let's see the name of the object is ob. So this object can be either a rectangle object or a square object. So basically it can receive any object or any of these objects, and inside that let us first print the area of this object, right? Because as you know that we have implemented the area method using which we can calculate the area of rectangle or the square, which is here. So now let us see what output do we get when we call this particular area method, right? So this is the only thing initially we will do inside this program. So first let us instantiate the rectangle class, and then we will pass that rectangle object into this function in order to see the result. So first let us say rc is equal to rectangle class, and we can simply pass 2 as the width and 3 as the height, and then we can just call the useIt function, and inside the useIt function we can pass the rectangle object as the input parameter. So now if we execute this particular code, then as you can see that we are getting the result as 6, and the reason for that is here we are passing the width as 2 and the height as 3, and then which is getting instantiated in this rc object, and then we are passing this rc object into the useIt function, and here we are basically invoking or calling the area method which is declared inside the rectangle class, and it is basically multiplying the width and the height, and it is giving us the result as 6. So this is working absolutely fine, right? So there are no issues here. Now let us make some modifications in the width and the height of this rc object inside this function. So what we can do is first let us just copy the width of this particular object. So we can say w is equal to ob dot width. So we have copied the width of the rectangle object. Now what we will do is we will update the height of this object. So what we can do is we can write ob dot height, and we can change this value to 10. So remember that here the value of height is 3, which we are passing into this particular object, but here inside this function we are updating the value of the height as 10. And now what is the result that we are expecting from this program? So we can store that expected result inside a variable called expected, and which will be equal to integer value of the width multiplied by 10, because here we have stored the width of this particular object and later we have updated the height of the rectangle object. Now the result that we are expecting after that is basically width multiplied by 10. And now let us compare this expected result with the result that we are about to get from the area method, right? So we can just print an f string where we can write expected result is expected, and we got ob dot area. So this will have our expected result, and this will basically give us the actual result that we are getting out of the area method, which is implemented inside the rectangle class. So now if we execute this particular program, so now as you can see in this result that our area method is basically giving us the expected output, right? So till now there are no issues at all. So our rectangle function is behaving exactly as how we would want it to behave. So there are no problems at all. Now let us see what happens if we basically instantiate the square class, and then if we pass that square class into this useIt function, then what behavior or what result are we getting? So first of all let us create a square object. So we can say sq is equal to, and then we can write the name of the class, and then we can pass the value of the size, right? So inside the square class we are just passing one single value, which is the size. So let us say we are passing the value as 5 initially, and then we can pass this square object inside this useIt function. So we can simply pass the square object as the input parameter. So this square object will now go into this useIt input function. So here again w will store the width of the square, which means that initially since we have given the value of size as 5, then initially the width of the square will be 5, and then we are manually modifying the value of the height of the square object here, right? So we are changing it to 10. So which means that our expected value as per the Liskov substitution principle would be 5 into 10, which is 50, right? But when we execute this code, let us see what we are getting. So when we execute this code, so you can see that we are having a problem here. The expected result was 50, but what we got from the area method in the rectangle class was 100. Now this is a problem. So now if you think about it, your square class is not logically wrong. It is behaving logically right actually, because if you modify any one parameter of your square, be it the height or be it the width, it would mean that you are setting both the width and the height as same, right? So your area will be calculated accordingly, and the result is fine if you think about it, because here inside the program, as you can see that you are changing the height of your square object. So when you change the height of the square object, then automatically your width is supposed to change when it comes to the logical behavior of your square class. But even then, you have completely violated the Liskov substitution principle. Because remember, Liskov substitution principle states that your derived class must be substitutable to the parent class, which means that your derived class must not change the behavior of the parent class. But here it is completely changing the behavior, because when it comes to your parent class, which is the rectangle class, if you pass a different width and the height, it will simply take those inputs and provide you the area result by simply multiplying the width and the height. But when it comes to the square class, it is basically making both height and the width as the same value, and which is logically correct. There is nothing wrong with it, but it is still changing the behavior of the parent class. And this is why when we are implementing a derived class which changes the behavior of the parent class, this kind of a side effect we will have in our program. And remember that when we understood about the definition of Liskov substitution principle, it says that the derived class should assume that it can substitute the base class without altering the correctness of the program. So I hope that now you understand the importance of that line, without altering the correctness of the program. So now as you can see here, that here the correctness of the program has been altered by the derived class, and that is because when you are changing the value of height, the width is also getting updated to the value of the height, and that is exactly why your expected result is different from the result which is coming from your area method. So I hope that now you are able to understand the kind of side effects that we may have if we breach the Liskov substitution principle. So always remember, whenever you are writing a class which is a derived class from a base class, then you must not change the behavior of the base class. Yes, you can add extra methods, you can implement different functionalities in your derived class, there is nothing wrong with it. But when your derived class is instantiated, then the behavior that your parent class had, that must not be modified by your derived class. And if you have changed the behavior of your base class in your derived class's objects, it would mean that you have violated the Liskov substitution principle, and you will end up having such side effects inside your program. So I hope that now you are clear that how you can ensure that you are following the Liskov substitution principle. So first example, we saw a very direct example where we saw that we must be able to implement all the methods of our base class into our derived class. If we are unable to do that, even if one method or one member is not usable from the base class to the derived class, it would mean that you are simply breaching the Liskov substitution principle. And similarly, in example 2, we understood that even if you are able to use all the methods of the base class into your derived class, but you are tweaking the behavior of those methods inside your derived class, then also you are basically violating the Liskov substitution principle, because now the objects coming out of your derived class will behave differently from the objects of your parent class, which means that your derived class objects are not substitutable to the objects of your parent class. So I hope that now you are able to understand what this particular principle means. So if you have any queries or doubts, or if you have any feedback or suggestions, then just let me know in the comment section. I will definitely respond to you. And also just let me know that if you need more examples to explain this particular principle, then I will definitely come up with more examples to explain this particular principle. But as of now, I hope that you were able to understand this particular principle, and also you were able to get value out of this video. So in the next video, we will understand about interface segregation principle, which is quite similar to this particular principle, but in a different perspective. So we will see that in the next video. So if you have understood about this particular principle, then I think it will be a complete cakewalk to understand the next principle that we are going to understand, which is the interface segregation principle. So I hope that you enjoyed this video. So if you like this video, then hit that like button, share it with other code lovers, and also subscribe to Code Framer for more videos in the future. Thank you, and see you next time.